Hey!
Hey everybody, welcome back to What's New in Android. I'm Dan Sandler from the System UI team.
I'm Chet Haase from the Android Toolkit team.
And I'm Romain Guy from, I still don't have a name for my team, so from the Android team. And you may remember us from other talks, such as What's New in Android 2017, What's New in Android 2016, What's New in Android 2015, What's New in Android 2014, not What's New in Android 2013.
We don't talk about that one.
We don't talk about that
No,
one.
that was the time that we had Jelly Bean 2 years in a row. It was brilliant. We didn't have to redo the logo or anything.
But now,
What's new in Android? What I like to call the Android keynote. Nobody else does, but I like to call it that. Because this is where we talk to you about all of the developer stuff going on in the Android platform. In particular, let's talk about Android P. Specifically, let's talk today about, oh, hang on, Android APIs.
First, we'll start with distribution. You saw in the keynote we introduced the dynamic app bundles. Tor's demo was pretty clear. It's pretty easy for you. All you have to do is click a different menu when you build your application, and we're going to save you some space. It's going to be faster and easier to download for your users to download your app. And I'm sure you have a lot of questions about it. So we have a couple of talks this afternoon at 5 p.m. and 6 p.m. Go there if you want answers, because we don't have them.
So you're going to see a slide a whole lot like this through the rest of the talk. I feel like the main function we serve in this talk is to tell you the other talks to go to. We're like the appendix. We're like the index for the rest of the conference.
Yeah, let's be
You mean
clear.
we're like obsolete, like vestigial? Is that what it is?
I don't like to think about that.
Okay.
Yeah, let's be clear. A lot of people back at work have done all the hard work. We just get to go on stage and talk about their hard work.
So speaking of that, let's talk about Android Jetpack. We heard Steph talk about this in the developer keynote. This is a set of components as well as guidance on how to build better Android applications. All of you are familiar with most of what is in Android Jetpack already. What we're doing is adding to it over time with stuff that's going to make it even better, and we're also improving it over time. One of the major steps that we're taking is what I like to think of as a refactor, because it's a refactor. My favorite thing about the support library is how the package names embed the release number in them. So for example, we support things like V4. Actually, we don't support V4 anymore. We have a Min SDK of at least 14 now, but it's in the package name. Isn't that a little bit silly? So we're doing away with that. We're doing a whole lot of tedious renaming, and we're also providing tools to make it easier for you to do the similar refactoring that you're going to need to do in your application, as well as in Android Studio. Everything is being renamed to something more appropriate called Android X. If you want to know more about the details of that, the renaming, as well as doing more modular, more fine-grained splits to make sure that you don't drag in too much stuff, go to the talk, learn what's new in Android Support Library. Also, there was an article that was posted on the Android developers blog about a half hour ago. Check that out for more of the details there. Let's talk about Android Test, which is part of this new Jetpack thing going on. Android Test is the ATSL stuff, the Espresso stuff that hopefully you are already using, really good ways to test your application. Now they provide first-class Kotlin support, as well as more elegant APIs for reducing a lot of the boilerplate. Here's a simple example. We used to have a way of asserting, which A, was not necessarily obvious in the parameters you were passing, also unobvious in the order of the parameters that you were passing, and then it would give you an error message that also didn't really help very much. So we have something a little more sensible now. You can assert that. It's actually working on the visible property, and the error message gives you something more that you can work with a little bit better. Go to the frictionless Android testing talk for more information about that stuff. Jetpack architecture is about the architecture components that were announced last year at I/O and then iterated with feedback from the community and finally went 1.0 in the fall. So we have the release parts of those, which includes all the lifecycle stuff and the view model stuff, as well as the room, the persistent data model stuff, and live data. So hopefully you are using that stuff already, at least in your new applications. And what we also have is recently we released the paging library for doing asynchronous data paging into recycler view. That was alpha, then beta, because that's how those things work. And now it's 1.0 this week. So please start using that. And we also talked in the developer keynote about a couple of new things that you should check out soon. Work Manager is currently in preview. There's going to be a talk about it. It's about job scheduling, but job scheduling in a way where we handle all the cases back in previous releases instead of you having to use specific approaches depending on what version and device that you're on. Also, navigation. It turns out that up versus back is a hard problem for applications to solve. We are making that much easier, and we're integrating with the tool to make it even easier yet. So go to all these talks. There's an overview talk as well as specific talks on navigation controller and work manager, and also a talk on recycler view and paging. Me? Again? All right.
It says your name on the slide.
I keep building suspense into this thing. What's going to happen next? Who's he going to hand the clicker to? Still mine.
It's still you.
OK, let's talk about battery. This is one of the ongoing efforts in Android to help the users, because it turns out battery is really important. We're all power users. Unfortunately, we just keep using the power. So what can we do about it? We can create these app standby buckets. We're going to monitor the usage of applications and see how actively the user is using it, and then make determinations about how much access that application has to ongoing things in the system, which are going to take up more battery. We also have background restrictions that the user has the ability to kick in settings. So if an application is behaving badly, let's say holding wake locks for long periods of time, or waking up constantly, or accessing services way more than they should when it's not on a charger, then we'll note that and expose that in settings, and then the user can take some action on that if they deem that necessary. Go to the battery session on Thursday morning to learn more of the details there.
So one of the things that we've been focusing on with Android P is privacy. Maybe that's what it stands for. So one of the things we've done is that when your app is in the background, it doesn't have access to the microphone anymore. It doesn't have access to the camera anymore. And it does have access to the sensor, kind of. So you won't receive the data from the sensors automatically. You can manually pull from the sensors, and you'll get a batch update. But the best thing to do if you want to get access to the sensor data is to keep a foreground service running instead. So no more microphone, no more camera for you. I think I've heard in the past that some apps were trying to stay alive in memory by playing a white noise or keeping the microphone on. Don't do that anymore. It's not OK. Kotlin, it's this little thing we announced last year. So we're busy. We want to make it better for all the Kotlin developers out there. I'm sure there's a lot of you here today. So some of the things we've been doing, the R team has been really busy with D8, R8, and Art itself. They've been looking at the bytecode generated by the Kotlin compiler. They've analyzed some of the bytecode patterns that were different from the ones generated by the Java programming language compiler. And they've been optimizing for those patterns. We've also been adding a lot of nullability annotations to our Java APIs, both in the core libraries, so libcore, and our support libraries to make it easier for you to use the platform APIs when you're in Kotlin. And finally, we launched on GitHub a new library called Android KTX. It's a set of Kotlin extensions for existing platform APIs. And the goal here is to try to take advantage of some of the Kotlin language features to make existing APIs easier to use. They're already easier to use just by using Kotlin, but with the extension, they get even better. And I want to thank the community because we've received dozens of pull requests and also bugs and feature requests from you, and we've accepted a bunch of them. So if you have ideas, if you have things that you'd like to see in Android KTX, please go to GitHub and we'll take a look at your PR. And this is an example of the kind of code you can write with KTX. If you want to create a bitmap, you don't have to specify it's ARGB 8888 anymore. You can call apply canvas to automatically create the canvas for you. It becomes this. And at the bottom, you can see, for instance, the destructuring assignment for a color integer. So you don't have to do any shifting or masking of the int into bytes. We'll take care of that for you. There is a talk by Jake Wharton on Thursday at 10:30 a.m. He's going to go through most of the extensions. He's going to talk about the philosophy behind the extensions, how we write them, what are the kind of extensions that we want to see in that library, what we're not looking for in that library. So before you do all the work and send the PR, go attend that talk to understand what we're looking for.
We already talked about the Android test stuff that is part of Jetpack earlier. That's probably a better, more holistic way to test your application. But if there's a specific situation in which you find it necessary or helpful to mock the framework, and I don't mean ridicule it because that wouldn't be nice, then it is possible to do that in easier ways now in Mockito. We are not changing the framework, but we're actually integrating changes into Mockito itself. So you can now mock final methods, and soon you should be able to mock static methods.
And Chet is making that face because he doesn't understand why that is so interesting to you.
and system-created objects like activity, eventually. Working on that internally, but it should be on the way eventually. A background text measurement, this is part of a bunch of smaller changes that we made in the text area. It turns out that measurement is really expensive. So most applications do text, and I would bet that the text operations in your application are some of the most expensive going on in the UI thread, which can contribute to jank. Wouldn't it be nicer if you could offload that to a background thread so that by the time you actually need to render the text or perform those operations on the UI thread, most of the hard work was done for you. So the observation is that 80 to 90% of the operations that are necessary for actually displaying text happen in text measurement. Well, we've made it possible, much easier, to actually perform this as a background operation. So we have a class called pre-computed text, and you can query that, and you can say, I want you to pre-measure this, and then you can set that text that's spannable on the text view later whenever you want. So you do it in a background thread like this. You say, create this thing, and then you can set that on the text view later when you actually need it. Should be much faster. Magnifier is something that if you're using the preview releases, you might see if you select some text, it pops up this little bar up above it and makes it easier to manipulate the cursor. That's really great for text, but the other cool thing about it is that it's also available for your applications for any other use case. So there's an API that allows you to pop up this magnifier for whatever happens to be in your view. So you can show this and dismiss it and use it for your stuff as well. So core functionality that we want in the system user interface, but also useful APIs for developers to use for their own purposes. I don't know if you've worked with your design department and they've specified something about text in your UI and, okay, well, I want this aligns, this many dips away from the top, and then I want the baseline on the bottom, this many dips away from the bottom, and then you have this interspersed vertical alignment stuff going on, and then you sort of puzzle with this for a while, and you basically futz with padding in all kinds of different configurations to sort of get it to where they wanted to get it. We have worked with that and created some new attributes and methods and properties for you to use that make that much easier. So we allow you to just pass us the information about the baseline alignment calculations that you would like to perform, and then we'll futz with padding on your behalf. Smart Linkify, I think of this as being Linkify, but smarter. So we already have the ability to ask for links in a block of text, and it'll detect things like phone numbers and addresses. But we also have the ability through machine learning models and stuff that you've seen through smart text selection to detect other entities. We can do the same thing with Linkify. It takes a little bit potentially longer, so you do this off-thread. So you would basically generate the links off-thread and then set it on your text view later using code similar to this. There's a text talk on Wednesday evening, so please go to that for more details about all of this as well as more.
So location, now you can take advantage of a new package, android.net.wifi.rtt. It's the Wi-Fi round-trip time API. It requires compatible hardware on your phone. It also requires a compatible access point. And it allows you to find a precise location indoors for the user's device. You need to request the find location permission, and you don't need to connect to the access point. So if you're building an application that requires locating the user inside a big building, you can take advantage of this API in Android P.
Accessibility has some improvements for navigation through the app, so it's easier for you to declare these functional blocks. Makes it easier for accessible users to understand how things are being grouped on the screen. There's an important talk on accessibility right now. No, that's tomorrow. Tomorrow. Okay, tomorrow. Hopefully it's tomorrow. I'm not sure that's correct.
It's tomorrow or 30 minutes ago.
Okay, all right.
It's on YouTube.
All right, yes it is, eventually. Like now, yeah, I think I got the day wrong. Sorry about that, it's now. If you're in the wrong talk, I invite you to go to the other one.
Oh, my turn. Security. New API in Android P, the unified biometric dialog. So we deprecated the fingerprint manager because there are more ways to authenticate yourself with your body than just with a fingerprint. Could be your eyes, could be whatever else that device manufacturers will think of next. So now we have a single UI for all devices and all means of authentication. We also have stronger protections for private keys. And very important, in your application, if you're using the API build.serial, it doesn't work anymore. The API is still there, but it basically returns bogus data, so you cannot rely on it at all anymore.
Various changes in enterprise, just a couple of them that are interesting. We made it easier to work with work profile apps or different profile apps by having these different tabs that you can associate with them, so they're not all mixed together, but you can actually have these whole sections of these different profiles. Also, you're allowed to lock packages to a specific task. You could have a launcher with just a minimum set of a group or a single application. That works in combination with the ability to have ephemeral users, which now gives you kiosk mode. So you will no longer have experiences like I had on a recent flight, as you can see from my blurry picture, where you see a movie and you wonder what operating system is running under that. So you swipe from the bottom of the screen, you see the ICS navigation bar, and then you press on the recent task and you swipe the movie away, and you confuse the heck out of the system.
I have to admit, that's what I try every time I'm on a plane these days. And it works a surprising number of times.
This is like fun for Android engineers. This is what we do.
Hopefully this is not linked to the plane navigation.
Now, is it OK? Can I talk now? Is that all right?
Very briefly.
Very briefly. All right, let's talk about, actually, a lot of the system UI stuff typically gets shown at one of the keynotes that precedes what's new in Android. So you've all seen a lot of the great stuff that users are getting. I'm going to talk to you about some of the stuff that, as developers, you might be interested in. The first one is display cutouts, AKA, well, there are other names for it. These are coming to the ecosystem all over the place, and so as a developer, you need to know where it's safe to draw and where it isn't. When you get your window insets on view, window inset something or other, you get a display cutout object, which gives you all kinds of interesting data about the cutout, but you're probably going to want to use something called window layout in display cutout mode on your window. So there's the basic way, which is I never want to overlap the cutout, just leave a black bar at the top or the bottom, whatever, I'm not all that interested. A little more advanced would be display cutout mode default, which is if you were already going to clear the status bar just fine, we'll let the app window draw underneath the cutout as well. So you'll get the nice action bar color extending through the status bar and extending underneath the cutout. Better still, or more advanced still, is short edges cutout mode, which means essentially anytime there's a cutout on the short edges of the device and we're in portrait, I will just draw underneath. You don't have to do anything special. And in that situation, you do need to look at the display cutout and ask it for the safe insets. Essentially, well, OK, I'm drawing everywhere, but you tell me what single rectangle of the screen is safest to draw in. And then finally, the cosmic version of this, you can do short edges, but you can actually get the bounds of the cutout as a region. So you will get the exact set of rectangles that are unavailable to you on the screen, so you can display UI in the corners if the corners are available, or if there's a corner cutout, you can move things out of the way so that it's visible in the center of the display. This is the most advanced version of it. And you can put the electrical tape away because you can actually simulate notches now in developer options on your device. This is really, really exciting. Slices actually was what we were calling it internally, and we liked it so much we just kept it. You've seen Slices now in a couple of keynotes. It's essentially something that we've discovered and learned about on System UI and in the toolkit over many years of dealing with remote views for app widgets, dealing with notifications. Essentially, the problem of getting content from your app into some other place. So Slices is our new approach to remote content that you can actually use to project UI into your own app or into other apps that support it. It's very structured. This is not sort of here's a canvas or an absolute layout, go nuts with it. We give you a structure to fill out and a whole bunch of very flexible templates in which to populate that data with some display hints so that the receiving end of the slice host, kind of knows what to do with it. These are interactive, these are updatable. This is meant to be something that holds rich UI, sliders, controls, live information, possibly videos, things that actually feel like real UI as opposed to a snapshot of something happening in a distant process somewhere. Slices are addressable by content URI, and this is how they're passed around the system, and how they're passed along to app indexing to be shown in contexts like search. And then finally, Slices is entirely inside the support library. It's entirely in Jetpack, so it's backwards compatible. You can use Slices all the way back to API 19. There's a great talk about Slices tomorrow, bright and early, building our interactive results for Google Search. Come to find out more about how all this technology works and how you can build your own. Related to Slices is actions. You can think of these as shortcuts with parameters. Romain likes to think of them as visible intents. This is essentially a deep link into your app with some additional payload. It's not just a link to music. It's a link to a particular album or something like that. And you saw these as well in the keynotes, showing up in a predictive space inside our app launching experience. actions you define in an actions XML file that goes into your APK or app bundle. And that too can get registered with app indexing so that search results and predictive features can show those actions. And there's a talk about this too. Thursday, slightly less early in the morning, integrating your Android apps with the Google Assistant. Notifications, there was a lot of great stuff about digital wellness and controlling notifications that you saw in the keynote, and I'm very excited about NP. I'm going to talk about some of the developer stuff, though, that we have in here. We asked users what notifications are most important to them. Users love messages, so we focused our energy in enhancing the messaging style API. You can do inline images now. You can do participant images and attach other metadata about the participant. And we finally now have UI for Smart Reply, which we've had on Android Wear for years. So when you use remote input.set choices, those will now appear as chips right in the notification, so you can respond instantly in the middle of a chat without leaving the notification shade. There's tons of other stuff, as usual. I had one other slide that we added about 10 minutes ago to this deck about notifications, and I'm just going to let that sit on the screen for a little while. So if you're doing something in the background the user still needs to know, but Android P does a much better job of allowing notifications that you may already have running testify to that background activity, including things like overlaying windows. So with that, talk about the runtime, Romain.
So probably one of the most important things for you as an Android developer is to understand our deprecation policy. It was announced a few weeks ago. Soon, we will require all the applications to target some of the newest API levels, and we're doing that to make sure that we can keep the security level of Android as high as possible, as well as performance and a lot of other nice things. So what does it mean for you? As of August this year, new applications published on the Play Store will have to target API level 26. And as of November this year, any update to an existing application that you publish on the Play Store will have to target API 26. And you can expect those numbers to go up over time. If you have native code in your application, we've been supporting 32-bit and 64-bit for a few years now. We will make 64-bit ABIs required as of August of next year. You'll still be able to ship 32-bit support in your application, but we will ask you to ship 64-bits as well. One of the reasons to ship 64-bit on 64-bit devices is that you get better performance and much better code out of it. If you want to know more about the deprecation policy, there is a talk tomorrow on Thursday afternoon, and I'm sure you'll have a lot of questions for the folks there. App compatibility, if you've tried the developer preview in P, you might have noticed something different if you're one of those naughty applications that use some of our private APIs. On Android, we have two types of private APIs, the APIs that are actually marked private, and then there's this weird @hide thing that we use in our source code. It's a Javadoc tag that we process specially to indicate that this is a public API for us, not for you, just for us. And we're a bit jealous because a lot of you are using them. So from now on, a lot of those APIs will trigger warnings in one form or another. It might be toast or it might be logs when you make an illegal call. For some of these APIs, we need to hear from you that you need those APIs for your application to keep working. Sometimes it's just an oversight. We didn't make the API public, it's just because we didn't think about it. So please go to this URL and let us know if there's an API that you think should be made public. We might say yes, we might also say no. We have three types of lists. I won't go into too much detail here, but basically if an API falls in the blacklist, you will not be able to call it ever. I'm not sure if we have anything in the blacklist right now, but those will evolve over time. So again, let us know what APIs you need.
This is one of the important reasons. This is why we ship previews. We need you to go out there and try your applications on the previews, because this is the time to find out when there's problems that either you can fix before the real release is out there, or you can let us know if it's a problem that we need to work on instead.
And that's Chet trying to increase his engagement with this podcast. So there's this podcast called ADB, the Android Developer Backstage, and in episode 89, they had, who did you have in the episode?
Brian Karlstrom.
Brian Karlstrom, and they talked about this app compatibility issue and what it means for you. So go listen to it. NDK, the release 17 of the NDK brings a lot of very interesting things. So first of all, the neural network APIs that were part of API level 27. We also have a new shared memory API if you do a lot of JNI. More importantly, we have finally asend, the address sanitizer, to make sure your code doesn't scribble all over the memory. Now you don't need a rooted device anymore to use it. And we also have an undefined behavior sanitizer. It can be very difficult to detect undefined behaviors in your C or C++ code, so now there's a tool for that. We finally removed support for the deprecated APIs. So if you still use ARMv5 or MIPS, MIPS 32-bit or 64-bit, support is gone. You should not be shipping those anymore. In the upcoming release, our release 18, we will remove GCC. So the GCC compiler was deprecated last year. Now everything is compiled with Clang in the NDK. We think we gave you enough time, so GCC is going away. So if you're still using it, now maybe you should not be in this talk. You should go fix your code. And finally, we added support for the simple perf CPU profiler, and we also have support in the IDE in Android Studio for native profiling, so you don't even have to type anything in your terminal. Graphics and media. The camera APIs are getting better and better. We've added a lot of things that we are using ourselves in the camera applications. For instance, we give you access to the timestamps of the optical image stabilization. So if you want to build the kind of stabilization we've built in our video recording, in the video recording part of the camera application, now you can. If your app is doing a lot of selfies and you're using the display as a flash, you can tell the camera that you're doing that, so it can adapt the exposure accordingly. We have support for USB cameras. I haven't seen any use for it, but I've heard some of you ask about it, so now it's available. Multi-camera support. There are some phones coming out there with multiple cameras in the back or in the front, I suppose. And now we can expose them as a logical camera that contains more than one stream of data. Image decoder. I'm sure a lot of you are familiar with Bitmap Factory. And if you're not fond of that API, trust me, we're not either. So there's a new one called Image Decoder. It's part of Android P. The idea is to make it not only easier to decode images, but also to make it possible to decode animated images. So Image Decoder can decode bitmaps, but also drawables, including animated image drawables.
There's this new thing called animated GIFs. I don't know, all the kids are using them. It's possible to actually load those now.
So there are a few concepts that you have to learn when you learn Image Decoder, and we're going to go through them in an example. So we have the concept of a source, we have the concept of the post processor, and finally the header listener. So this is what the API looks like. First, you have to call create source on the image decoder. The source can be an asset, it can be a file descriptor, it can be many different things. And the goal here is that once you create a source, you can decode multiple images from the same source. This is particularly useful if you want to build thumbnails. You can decode the same source once at high resolution, once at lower resolution, or even intermediate resolutions. And that can be done from multiple worker threads. Then you can call decode bitmap, you pass the source, and you can optionally pass a header listener. So the header listener here, we have a lambda. It gives you back the decoder itself, the metadata about the source, about the image, and the source. And it's inside the header listener that you can set the options. So in Bitmap Factory, you had bitmap factory.options that you had to pass to decode. Here you have to wait for the header listener to be invoked. So for instance,
we should point out, too, like that set target size, that's kind of a fundamental difference where the old bitmap...
It's up there for that.
No, I see that. It's right there. If you would all look right there. That's a huge difference. Like before, if you wanted the right target size, you needed to work with what, in density as well as...
in sample size, in density, and do a lot of trickery.
We didn't know how they worked either.
Yeah.
So, a lot easier now.
Yeah, usually our answer was figure it out. Anyway, so now you can just tell us what size you want the bitmap to be in, and we'll take care of it, finally. And you can also set a post-processor. So a post-processor is something, a simple interface. It gives you a canvas, so you can draw on the bitmap right after it's decoded, so you can add, I don't know, a header, like a title or some metadata on it. Media, we are adding support in the platform for the HDR profile of VP9, so you can play HDR videos in your applications. YouTube was doing it, but they had their own way of decoding videos. If you're on a device that doesn't support HDR, the playback will be in a low dynamic range instead, but on a device that's capable, like a Pixel 2, you will be able to see the HDR stream in all its glory. We're also adding support for and bear with me because it's a little bit confusing, a format called HEIF, it rolls off the tongue, the high efficiency image format. So it's based on HEVC, which is also called H265, and the file name extension is commonly HEIC. I don't know why they use different letters, but that's what they did, so we have to deal with it. So it is a container, and it can store multiple images. So you can use it to store a single image with higher quality and higher compression ratios than JPEG, for instance. JPEG is a lot easier to say. I like JPEG. But you can also store multiple images if you want animated images or short movies. This is part of the support library, or I guess Jetpack now. And this is not this is not part of the compressed API that you find on Bitmap because it's a container. It works differently. So this is what it looks like. You have to create a builder. You have to tell us the path where you want to output the file. You have to give us in advance the width and the height of the image. And the source of the image can come from a bitmap, but it can also come from a surface. So you don't necessarily have, for instance, if you're doing GR rendering or if you're doing video playback, you can encode that directly as an image. You don't have to go through an intermediate bitmap. And then when you call writer.use, you can add multiple bitmaps. In this case, we're adding only one. And when you call stop, we write it out.
I should point out, too, that even though it's spelled H-E-I-C, it's pronounced GIF.
Right. Go.
What are you still doing here? Vulkan, so this is the slide that I'm excited about. Very few of you will be. And I'm sure you will be super excited about things like subgroup ops and YCR-CB formats. More seriously, anybody who's building middleware, for instance, the Unity engine, the Unreal engine, or if you're building games, Vulkan is a low-level graphics API that gives you a lot more control over the GPU, so you get higher performance code. And Vulkan 1.1 adds new capabilities that were not possible in OpenGL, but it also closes the gap with OpenGL. So for instance, the support of protected content. You're not able to play back protected content in Vulkan before, so that will unlock a lot of things like video players, for instance. Neural network APIs, they're not technically part of P because we announced, they are part of P, but we announced them in API level 27. You might have missed that. It's a C API that's designed for machine learning. It's also a fairly low-level API. It's meant for basically playback of trained models. So things like TensorFlow are built on top of the neural network API. So you would use TensorFlow to do all the learning, and the neural network APIs can do basically the inference on device. The interesting thing is that we're also unlocking the access to the DSP that we use on Pixel 2, so you can get hardware-accelerated machine learning effectively on select devices. AR Core, you just saw in the developer keynote, a couple months ago we introduced AR Core 1.0. They just announced AR Core 1.2. This takes care of tracking things in the real world. The problem is that you had to write a lot of OpenGL code, and it's not always pleasant. So to make your life easier, we're introducing support in the emulator. So when you create an AVD, you can specify a virtual camera stream for the back camera, and you get a full 3D scene, and it works in any view that displays the camera stream. And using the keyboard and the mouse, you can just navigate around the UI. You even get patterns on that fake TV screen, so you can do image recognition and pattern tracking, that kind of stuff. It's available today. Also, we have Synform, so they already talked about it in the dev keynote. I won't talk about it too much. I will only say, this is what I've been working on for the past few months, so I still don't have a name because we did that with Daydream, but anyway, that's what I was up to. And if you want to know more about Synform, there is a talk tomorrow afternoon at 5:30 p.m., and we're going to talk about the underlying tech and how to use the API. And finally, Chrome OS. On Pixelbook, you can now run Linux applications on your Chromebook, and in particular, you can run Android Studio. I believe there are some limitations, but one of the things you can do is run your Android apps as apps on Chrome OS, so you can use Chrome OS as a full-blown Android development platform, I guess, whenever it's available. Many more sessions today, tomorrow, and Thursday. We'd also like, I said that earlier, there's a lot of folks back home who've been doing all the hard work. We're just talking about it. So thank you very much to all the engineering teams and the PMs and the designers and tech writers, everyone who made this possible. We didn't do anything. We're just here to hear you be happy.
Some of us did even less.
Yes. Anyway, and that's it for today. So thank you very much.
See you at the Sandbox office hours. Bring your questions.
Yes, we have Framework office hours. There's Android Sandbox running all week.
We've done our best to bring as many people from our teams here to be able to talk to you about these new features, these new APIs, as possible, because we know you can't get that anywhere else besides Google I/O.
And also, there's an overflow session for our overflow area. I can't remember where it is exactly. Most of the speakers from Android sessions will make their way afterwards. So if you can't get your question answered at the session, you should be able to find them after that, like us there now. Thank you.